cable or chain lock, you can't quickly sever a U-lock with a pair of bolt cutters. It takes large, conspicuous tools, not something a thief can likely get away with unobserved. U-locks come in various sizes, so that you can lock your bike to different structures, from thin bike racks to thicker tree trunks. The shackle and lock are made of hardened high-alloy steel, which is resistant to cutting, sawing, and twisting. To shape the shackle, workers load steel bars into a computer-guided bending machine. The machine applies more than 25 tons of force to bend the bar in the shape of a U. The machine also notches each end of the shackle. These notches are what receive the locking bolts. To make the steel hard enough to be tamper-proof, they send the shackle to an outside facility for heat treatment. This demonstration recreates a small part of that complex process, which is to heat the shackle to almost 1500 degrees Fahrenheit to rearrange the molecular structure. Cool it in oil to set the hardness of that rearrangement, then reheat at moderate temperature to restore the flexibility the steel lost due to the previous steps. When the shackle returns to the factory, a laser machine precision measures and, if necessary, corrects the dimensions as per specifications. Then the shackle is dipped in durable anti-corrosion paint. Once the paint dries, an automated machine slips a PVC tube over the shackle. Next, they screw a plastic bracket to one end of the shackle. This connects to a corresponding bracket you screw to your bike frame to mount the lock on the bike when you're cycling. The rectangular block that houses the locking system is called the lock body. It too is made of hardened steel. An automated press punches holes on the ends for the shackle and in the middle for the lock cylinder. The locking system has a housing in the center for the cylinder. Workers mount two metal plates over it. When you insert the security-coded key in the cylinder in turn, the cylinder rotates within the housing, and the plates move apart, triggering other components to lock the inserted shackle. The cylinder is made of brass, a relatively soft metal, so there's an impenetrable steel plate on top to prevent a thief from drilling into it. Workers give the cylinder grooves a squirt of grease, the housing as well. Then insert pins into the grooves. These act as blockers, preventing the wrong key from opening the lock. With the correct key, they give way, enabling the cylinder to rotate within the housing. This spring applies tension to the cylinder's steel and drilling plate, keeping it in position so that the key inserts easily into the cylinder. On each side, workers insert a lever and bolt. When you turn the key to the lock position, the lever pushes the bolt into the shackle's notch, immobilizing the shackle. This component spring loads the bolt to prevent the inserted shackle from popping out prior to being locked. A pneumatic machine inserts the locking system into the steel lock body. A two-tone plastic cover gives the U-lock a snazzy appearance and makes the surface easier for the cyclist to grip. Here's how the lock works. When you turn the key, the cylinder rotates. This moves the two plates over it outward, triggering the levers on each side to hold the bolt in the shackle notch, locking the shackle in place. Every lock undergoes an opening and closing check. Random samples are subjected to more extensive quality control testing. It takes 13 tons of cutting force to break the steel, far more than even this larger than typical bolt cutter can apply. This torsioning machine measures how much twisting the U-lock can withstand. A bike robber would have to apply more than 350 pounds of force with a crowbar. The bike owner, on the other hand, needs only the coded key. The native North American teepee was designed to be a home where the buffalo roamed. Centuries ago, tribes were constantly on the move hunting the buffalo, which was their main source of food. Easy to pack up and reassemble, the teepee served as a portable shelter for this nomadic lifestyle. Today, people are rediscovering the appeal of a cone-shaped tent with a cook fire inside, and that's put the teepee on the comeback trail. No need to hand-stitch teepees anymore. Today, they produce them at a factory using industrial sewing machines. They start with the front panel. It's 3 layers of canvas and vinyl. They sew details like pockets for poles to open smoke flaps, and rectangular patterns to prevent stretching and tearing, from holes for lacing the front of the teepee together when pitched. The sewer now chops through the 3 layers of fabric with a chisel to make those holes. Another sewer stitches strips of buffalo hide to the door opening to make it more rugged. Using a pattern as a guide, the next worker cuts another panel on a slight curve. He then pieces together panel after panel to construct the rest of the teepee cone. He reinforces the hem with heavy nylon webbing. He tucks loops between the webbing and the fabric and secures them with more stitching. The loops will be used to stake the teepee to the ground. The team stretches out the completed teepee cover. An artist maps out some lines for painting on the fabric. There's 73 yards of it. It becomes a huge canvas for traditional artistry. The designs are Southwest American in style and highly symbolic. Circles can represent phases of the moon or the sun. A sample of the artwork has been drawn up beforehand for the client, and the artist refers to it as she works. She brushes exterior latex paint thinned with water around the perimeter of the designs. Then she soaks up paint onto a pad and presses it to the fabric within the painted lines. This avoids brush strokes and produces a flat finish that almost looks like dye. With the artwork complete, the teepee cover now makes a colorful statement. Outside, an employee shaves the bark off young trees to prepare the poles. There are 17 per teepee. Each one is 27 feet tall, the height of a 2-story building. A 2-person team now arranges 3 of the poles in a specific sequence to build the tripod that is the basic framework of the teepee. The assembler lashes the poles near the top with thick rope and a tight knot. He leaves a length of rope to dangle as they raise the tripod. The rope will come in handy later on. The arrangement situates the door pole east towards the rising sun and away from westward winds that could interfere with the cook fire. The team props up the remaining poles between the main tripod poles. The first 2 groups of poles form the front of the teepee, and a 3rd group forms the back. The assembler grabs the rope that still dangles from the central tripod, and from the ground, winds it around all the poles, where they meet at the top. The last pole is called the lifting pole. It's used to lift the painted teepee cover to the wood frame. They unbundle the cover and wrap it around the poles like a blanket around a person's shoulders. Once the fit is nice and snug, he laces the front panels together using willow branches for lacing pins. There are 18 pins in total, fastened above and below the doorway. He pegs the canvas to the ground, and then installs 2 last poles for opening and closing the smoke flaps from the ground. Traditional in design, with modern-day materials and construction, the teepee is still an idea worth pitching.